So let me do maybe this problem, 20 and 21, and same way then you can proceed to others as well. So so you have this problem, you have to use Euler's to find the approximation at 1.4. Your initial condition are given up here. So you are given, let's just write down the crude scheme first. So you are given x naught to be as 1 starting point and y naught is 4 at that starting point. Then you move on to x1 will be your 1 plus 0.1. So this is going to be 1.1 and you have to just do here 4 steps. X4 will be 1.4 and we have to find y1 here. To get y1, the first, so we have to find basically all these and then only we can get y4. So y1 will be, depends on the slope up here because the scheme is due to definition of differentiation. So from the definition of differentiation, we can say y1 will be nothing but y naught plus h times f of x naught y naught. So this will be nothing but h is your 0.1, f is your x naught, and then square root of y naught, and y naught you already have it. And that's how you get y1 up here. You repeat this whole procedure and your y4 will be same manner, nothing but y3 plus 0.1 and if we are going little bit further in the x interval, we are picking the previous value of x. So that way here we will be picking 1.3 times square root of y3 and so on. So let's go to now Excel and put all this scheme back in the Excel. So we are creating a column up here of x. Then we will be creating a column of function f of xy slope field. And another column will be giving us new y approximation. So x first, initially x is 1. And then you want to increment x. So you would put an equal sign, select the previous box, add 0.1 in this, and then you can just scroll it. Either you click on this double box or you just scroll it. It will fill up your entries. Okay. Then for f, y initially is 4. We already know it in the problem. So I'll just enter 4. And then we will find what is f of xy at this value. So xy is nothing but x naught, which is this, times square root function sqrt, and you put this cell value C2, select this cell. Is it big enough or okay, is it good now? Okay, very good. Okay, perfect. So this one will be equals to, we are doing the previous equation. Right. So we are taking x value and then we are multiplying it with the, I'm not sure I finished it up, so I'm just doing it again. So this is the f value. Now once we have f value, we can find the first y iteration because this is initial value of y. So first y iteration will be nothing but equals to y initial which is this cell, plus h, which is 0.1 in this problem, times the function value, which is your this cell. And you hit enter and you get a value. Huh? So this is back up to here. This was C2, and then I multiplied with 0.1, added into the previous cell. So I got here this, and now it's just a matter of so make sure always to update your cells, because you will see, and don't select this cell because this cell does not contain any formula. So the moment you click here, double click, all entries will become 4. But if you hit double click on this one where formula has been inserted, you are going to get the values. Now if you go back up and see what is the value at 1.4, this is the y approximation at 1.4. That's it. And you have to do it for every problem on Euler's. You have to do just like this. Then coming back to the improved Euler, the same problem we are going to do improved Euler now. So let's go back and understand improved Euler scheme first. So improved Euler scheme runs like this. So is this problem clear to everyone? You can do it, right? Okay, good. For improved Euler, you have to consider intermediate step of improving the approximation. So first step would be, in the same problem, you are going to find Z1, which is through Euler's scheme, y naught plus h times f of x naught y naught. Then once you have Z1, you are going to find y1. And this is your new y, which is your approximation of improved Euler. So you are going to do it like y naught plus h over 2, and you are taking average of two slopes, so that way you are going closer to your exact solution. Okay, so we are taking average of f of here, we are taking x1 z1 up here because we are finding it x1, and then we have to take up here the another value would be x naught y naught. That's right. Okay, just to double check. And scheme will keep running like this. If you want a real derivation how this expression is coming, I highly encourage you to watch the other video, because there's no point in spending time here. Let's just do the example. So this is how the scheme will come, and then you go ahead and do Z2 the same way. Z2 will depend on y1, the approximation which you have obtained, h times f of x1 y1, and then you find y2 similarly by using the previous approximation, averaging the two slopes, getting closer to the curve. X2 z2 plus f of x1 now in this case, and y1, and so on, and keep marching like this to get approximations at every value. y at x1, same, this is the notation I am using in this all these indexes. So z, same way, z2 becomes, z2 is same as z of x2, and so on. So this is the notation I'm using. And here xi is nothing but x0 initial data plus I times h. If it's 1, you multiply by 1. If it's 2, you multiply by... so you are not multiplying, right? You're adding, but in that number of steps, you're going to get it. So for example, like x1 is your x0 plus h, and x2 will be your x1 plus 2h. So this I represents how much step size you're adding, the multiple of step size. Okay. So this scheme is clear. Second order scheme, because two times we are evaluating slope, and much better than Euler, because why better than Euler? This we are doing averaging. So if you see geometrically, how will this look like? Very quickly I'm going, and then we will just put all these in the Excel. It would take only 5 minutes. So where is my x naught? Say my x naught is here. My x1 is going to be somewhere here. So if my curve looks like something, say this, slope at this value, this is y naught then, that means. And slope would be somewhere like this, tangent to this curve, having a slope f of x naught y naught. Then once you move forward little bit, you are computing z1, right? So z1 is what? z1 is y naught plus h times f of x naught y naught. So where will be z1 in this whole picture? Can you tell me where is z1 in this picture? z1 is this. You know what is y naught. Y naught is right here. You know x naught is right here. You know you don't even need any x1 here. Slope is here. What will be this? Where will be the z1 in this picture? Depending on the nature of the curve. Slope is going to keep, if I see my curve, my slope is going to here be positive, right? Do you agree with that? Okay. So that means this quantity is going to positive. So this is somewhere maybe can go up somewhere here, depending on uh, this h. So then if you have a vector up here, which is f now, f of x1 z1. So basically you are trying to find now f of x1 z1 up here. So these two vectors, when you add, you are in some sense making a diagonal up here of these two vectors and getting closer to the curve. Do you see that? So zoom in this figure. Then I have somewhere, say, if I'm thinking like this, I'm zooming this figure. So this, I have two vectors up here. Addition of these two vectors is going to be something like this, which is going closer to your curve. Curve is your exact solution of the differential equation. Whereas in Euler's, you are not doing any averaging. You're just computing slope and putting the equation. Okay, let's now put it in Excel. So going back up here, you have x column, you will have z column, you will have f of xy column, you will have f of xz column, you will have y approximation, new. Okay. So now x is going to be same way, just 1 first, and then equals to the cell plus 0.1, enter. Fill in some entries up here, and then we have to be a little careful up here. We'll just place initial data, what is y initially at x. Okay, then we have to find, if we go back up in this sheet, you see we have to find f of x naught y naught to get z. So I am going to compute f of x naught y naught now. So in this, going back up again, this is equals to x naught is this times square root of y naught, which is this. So this cell is x naught initially is this plus square root of this cell. And you know what? It would be easier if I... Oh no, hold on. So I want to... First I'll remove this. Then I'll... No, it's still taking the value of it. I am just trying to put a text on the top so that I don't have to keep go back and forth. The moment I hit it, it selects the cell because I am already on this cell. Okay, good. So this is the cell which we are using. Okay, now coming back to the z. Z will be nothing but, let's put some space up here. And I need more space for y. Okay, so z will be, again the formula which we are going to get initial value of y plus h times 0.1 times, now which value of f we are taking? This one, right? I'll slow down a little bit, just keep track of what I'm doing. So I am taking now the scheme. H I already have, y naught is 4, f of x naught, y naught is what we have computed just now in the column. So I am using all these pieces and put them together up here. So I am selecting this cell now. And we are going to get now the value of z. Z is Euler. Last is this one. This is going to be, again, you are making use of what to find this? You need x1, you need z1 to get this cell. But okay, so let's just do x. I'm not taking initial data up here. I'm just taking this cell times square root of my this cell. Because I need f of x1 z1 to find y1. Go back up here in the scheme. We need f of x1 z1 to get y1. So x1 is 1.1. z1 is what we have just now computed. So we are going to find this in that column. Not f of x naught z naught. If you want, I can write down here. Yeah, it might be confusing. So I am starting here with x1 z1. Here I am starting with x naught y naught. Yeah, so keep this in mind that um, we are not picking this value x naught here. We are picking the x1 value. Okay, now it's a matter of just put this cell as small as possible, y. So y is depends on initial data plus 0.1 divided by 2 can be written as 0.05, and now you are going to add these cells, this cell plus this cell, to get your new y approximation. H over 2, 0.1 divided by 2. So going back to the scheme once more quickly, y1 is y naught plus h over 2 f of x1 z1 plus f of x naught y naught. So this is we computed in one slope column. This we computed in another column containing slope. H is 0.1, y naught is 4 initial data, y1 we got then putting all these pieces together as 4.2.271645. And if you, in the Excel, if you little bit scroll up, it starts sometimes giving you, if there are decimal digits, start pulling up those numbers as well. Right. So now it's just, now you just have to, the moment you will double click all these cells, you are going to get different values, but you have to keep updating them. I'm not clicking on 4 again. Just, I always prefer to make sure that they are all updated. So again, double clicking on this rightmost small corner, and yes, they are now. So this is what is your approximation through improved Euler.